until it's to size. If you take it out of the chuck for any reason, it will never go back in the same place, and it'll process, and you'll never get it round. So leave it in the chuck until it's done and it fits your cylinder, okay? So at this point, I'll take an initial measurement. I'm gonna set this now to 0, because that's my starting place. So again, we should be near 620. We have to go take a little bit more, and survey says, oh, look at that. We're at 619 on our size. Now we're working to 4 decimal places with this guy, not 3. And it can be a little intimidating trying to work to that level of accuracy, but we're going to need to. So you're going to need to remember how to read the tenths on there. I will tell you that these micrometers that are in the blue boxes are a little different. Instead of having the 10 lines that would appear around here, this one only has 5, because on the thimble scale, remember on the other micrometers we had 25 divisions. This one has 50 divisions, okay? And the reason for that is every other division is a 0.5 thousandth, 0.0005, right? Yeah, 3005. To denote the 0.5 thousandths, right? And so if you go past that, you'll add that, whatever the lines are, to get your 8, 9, and 10. That makes sense? Okay. If you're having trouble, come get me. We'll walk through the process again, okay? But you definitely want to use your micrometer for this portion of the exercise, right? On the other thing, calipers will be just fine. We're not going that close, but this has got to fit. So let's just say, for example, my target, I measured my cylinder, is 0.499. I want to try to get very, very close to 499. So I'm at 619. So presumably I would take 20 thousandths off, right? I'm sorry. 499 from 619 is 120, isn't it?
Yes.
Yeah, 120. Yeah, 120 exactly. All right, so I'm at 0. I'm going to take 40. Even. So 575, reset that to 0. So 20, so 575, I'm going to take off 76. So 20, 40. The point here is to measure and measure often, especially when you're getting really close. I should be getting fairly close to 0.5. And I am at 5. 45, 28. I'm at 528. So I need to take off 29 to get down to 499. One of the things that's going to happen as you're taking these cuts with this brass, is this is going to start getting hot, okay? Brass will swell like anything else, right? Not as much as aluminum, but it will swell up. So if you've taken a lot of material off, just stop, take a break. Let this cool off. If it's too hot to touch, right? It's swelled up a little bit. So if you can touch it, it seems relatively cool, great. Now I'm ready to proceed. I'm gonna measure it one more time. Now it's cooled off just a little bit. Let's see if there's any difference. And there's about 2/10 difference now. I'm at 527 and 527.8, right, to 4 decimal places. 0.5278, I don't even know that. All right, so I'm gonna take at least 28 thousandths to see where I'm at. So I'm gonna take probably 25 and 3. I wanna sneak up on it, okay? So let's do that. So there's 10, take 20. Since I know I'm super close now, I'm hopefully within 4 thousandths of my target, I'm going to take a couple of spring passes before I remeasure, just to be sure. So according to this, I'm at 5045. So 505 should do it. So let's do 2, 4, and we have to, of course, interpolate between there. I'm going to go about 3/4 of the way between 4 and 6. Should be 505 roughly. Dead on. Right, so if you take your time, it is possible to hit it. So now we've got the sharp edge. I'm going to leave it in here for a couple of reasons. Let me go grab one of my cylinders real quick. So you're going to want your cylinder. Before you remove it, you can kind of do a quick test fit. So that fits nicely, right? I want everybody to come up here and take this cylinder, just kind of slide it back and forth so you know what you're looking for in terms of feel. So give it a try. Okay. It should slide easily. If it feels like it's going to get stuck at any point, stop. Don't force it, okay? Go back and double check your measurements. Only once I've verified that my cylinder fits the piston will I then commit to remove it from the lathe. Okay, no earlier. Now, before I take this off of here, I'm going to want to chamfer the end of that. Now we're going to do another heavy chamfer, so I'm going to do this face here, then I'll probably extend it out and do the back side so you know what you're looking for. All right, so dive in here, take a look at that. That's what you want to do to the end of your piston. A heavy chamfer. The reason for that is that if you look in the cylinder, at the top of the cylinder, that lead from the reamer has an angle, and the angle on this is designed to fit up in there so it doesn't get hung up. Okay? And you're going to want to do the same on the back end. The other reason we do that is if we don't knock that sharp edge off, because of how this works, as this thing is going up and down, the cylinder is being forced side to side, so there's a side load on the piston in there. If you leave that sharp edge in there, it will literally start carving aluminum out of the inside and turn the inside into an hourglass. Okay? And so by relieving the sharp edges, it stops that from happening. So I'm just going to extend this out. Again, some folks get nervous this close to the chuck. Put it in here. You could do that with the file, or I can use my tool here. And for those of you filming, you might want to swing around here and video from this side to see what I'm doing. I'm going to use the back edge of the tool here to come in and just very gently machine the back just like that. Just come in until it cuts that taper on the back side, just like that. Okay? Easy enough to do. That way you're not in here with the file right up against the chuck. Okay? And so, Viola, right? Here is my finished piston. It fits really nicely, so much that I can, right? That's what I'm looking for. And there's no oil on this yet. So if I put a thin layer of oil in this thing, I can easily pull a vacuum with this, right? Okay, so that's what we're looking for. The sound of success. All right, and that's it. Now, you're not necessarily going to have to drill the hole today, okay? If you want to wait and do that next week when we're doing all the other little things. It doesn't take very long to do this, so let me walk over here to the mills real quick and just kind of visually walk you through what you need to do. So you're going to want a parallel for sure, plain device, standard fare. So I'm going to use the next to the tallest parallel in here, just one. Set that in there. I'm going to set my part in here like this and butt it up against the jaw. I will then snug this down, and you're going to want it reasonably tight. I know the size of my piston, correct? All I got to do now is use my edge finder, come in, touch off, go to the middle, touch off the end of the piston, move down exactly 1.38. Then I want a center drill with a number 2 center drill. Right, there should be one in here. So this little guy right here, it says on there number 2. Number 2 center drill. You're going to want to center drill about halfway up the angle here, while the parallel's under there. Then you're going to switch to the drill you're going to use at point 157. Notice there's a +0, I'm sorry, a +5 -0 tolerance on it because we've got to fit a pin to that. So we need 157 for sure or slightly bigger, okay? You will start drilling the hole, go about halfway, then you're going to push the parallel out of the way so you don't drill into my parallel, and gently finish drilling the hole. If you're too aggressive about pushing the drill through, or you've not checked your directional rotation, what'll happen is it'll push on the end of this thing, and just to over exaggerate it, what'll happen is it will do that. It'll drop, which means that pinhole will no longer be perpendicular to the line of action. The pin that goes through there that drives our mechanism won't work correctly and it'll bind up, okay? So it's imperative that this stay flat at all times, okay? And that's it, and we're done, all right? So hopefully you've got enough information now. So let me go grab the tool that we need to measure the cylinder, and I'll show you how that works really, really quickly.
It's a pretty long video. Yeah, I know, right?
Scan it around here. These you're more familiar with. Okay, so this is an internal bore gauge, okay? This is a Starrett set that goes down to T9C, all right? So we can measure bores. The way this works is there's a thumb screw on the back side of this, and as I screw this inwards, it pulls a wedge in here and spreads these jaws out, okay? And we can very quickly, I'm gonna set this just so you got, and I'll pass this around. Got it. All right, so what we're gonna do is, so notice the parting line here, all right? So we're going to measure, we're gonna rock this thing back and forth all the way down the bore, and then we're gonna turn it 90 degrees and then do it again, okay? Because this may not be a true cylinder. Sometimes it actually turns into a bit of an oval, and you can actually see it with this cylinder a little bit, okay? Because when I turn it this way, and if I start at the top, at the very top, I'm just gonna rock it back and forth. You'll feel a little bit of drag. And what we're looking for is the tightest point inside there. So if it gets really, really tight like it does right there, I'll readjust this to feel that same amount of drag that I had at the top, and then continue. So if it gets really loose, we're in good shape. And we're characterizing the cylinder to see if it actually is a true cylinder, okay? It's not gonna be, okay? But we need to know what the smallest point in that cylinder is. So once I've found that smallest point, so I don't get any drag this way, but I do feel a little bit right about midway at 90 degrees, right? So then I wanna know, what is that diameter? I can now take my micrometer. I know it's going to be something less than 0.5, I'm hoping. All right, well, it just turns out that it is dead on exactly 0.5 inches at the smallest point in the bore. So it means everywhere else it went slightly oversized. That's good news for me because if that's 0.5 and I want 1,000 smaller than my target, my drawing says what size do I need to make my piston? 499, right? Which is what I did with mine, okay? And that's your target. So whatever you measure, subtract 0.001 inches, that's your finished diameter for your piston. If you achieve that size, it should fit your cylinder very nicely, okay? If you're having trouble using this, having trouble measure, come see me and I will help you do that. But you need to do this first so you know what your target is before you start working on your part. Remember, once you chuck it in there, you can't take it out until it's done. Now on the other end, doing just the end of the piston, the rod there, you can finish that down to size without having to do this first, right? So however you want to approach it. All right, so that's the procedure. I'm going to leave this. This is the only one in captivity. Don't lose it. I'm going to leave these laying right here. So when you're ready for them, take your measurement, write it down somewhere, and you're golden. Okay? Any questions? No? Everybody's got it?